Hello everyone, this is Abhishek Mohanty and welcome to lecture number 4 of the chapter Electric Charge and Field. In the previous class, we had discussed about Coulomb's law, which helps us to calculate the electrostatic force between two point charges. In the previous class, we had discussed that if we have two charges Q1 and Q2 separated by a distance r in vacuum, then the electrostatic force between the two charges is given by F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by r square, and epsilon naught is known as the electrical permittivity of free space or vacuum. So using this formula we can easily calculate the electrostatic force between two point charges. But if in a system, if we have more than two charges, let us say 3 charges, 4 charges, 10 charges, n number of charges, then how to calculate the force on a given charge? So that is given by the superposition principle. So today's topic is how to calculate the force on a given charge if in that system we have more than two charges. So the topic name is forces between multiple charges or superposition principle. So this principle states that when a number of charges are interacting with each other, the total force on a given charge is the vector sum of the forces exerted on it due to all other charges. And the force between two charges is not affected by the presence of other charge. So suppose in a system we have more than two charges. Let us say this is a system and here I have, suppose I have 4 charges. This is Q1, this is Q2, this is Q3 and this one is Q. So in this system I have 4 charges Q1, Q2, Q3 and Q. And all these charges, they are interacting with each other, because we know that whenever there is interaction between two bodies there will be force. So due to the interaction there will be electrostatic force between them. So the principle states that when a number of charges are interacting with each other, then the total force on a given charge. Suppose I want to calculate the total force, total electrostatic force on this charge small q. I have to calculate the total or the net force on the charge small q. And how to get it? The total force on a given charge is the vector sum of the forces exerted on it due to all other charges. So since I am interested to calculate the total force on this charge, we know that on the charge Q, Q1, Q2 and Q3, all of them, these 3 charges will exert force. Suppose assume that all the charges are positive charges. So Q1 will repel Q in this direction, Q2 will repel Q in this direction and Q3 will repel Q in this direction. So Q1, Q2 and Q3, all of them will exert forces on the charge small q. Suppose the force exerted by Q1 is F1 vector, force exerted by Q2 is F2 vector and force exerted by Q3 is F3 vector. It means there are 3 forces acting on the charge Q. So how to calculate the total force on charge Q? You have to take the vector sum of the 3 forces, because we know that force is a vector quantity. So whenever there are multiple forces acting on a body, to calculate the resultant force or the total force, we have to add all the forces vectorially. So I can say that the resultant force or F net means the net force on the charge Q is equal to the vector sum of the forces due to all other charges. So if you exclude this charge small q, then we have 3 other charges. So all the 3 charges will exert 3 forces on the charge q, and that's why to calculate the total force we have to take the vector sum of all the forces. And remember that whenever you are calculating the force between two charges, then that force is not affected by the presence of other charge. The force between two charges is not affected by the presence of other charge. Means when you are calculating the force exerted on Q due to Q1, you should ignore the presence of Q2 and Q3. So here what will be F1 vector? F1 vector will be K Q1 into Q divided by, let us say the distance is R1, this distance is R2 and this distance is R3. So F1 vector will be how much? K Q1 Q2 divided by R1 square, and it will be directed along this direction. Let us say this point is O, this is A, this is B, this is C. So F1 vector will be along AO, along AO. Similarly, F2 vector is equal to K Q2 into Q divided by R2 square, and that force is along BO. So you can write the expression for all the three forces. So F3 vector is equal to K Q3 into Q divided by R3 square, and the direction is along CO. So after writing the values of the three forces, we can add them vectorially to get the resultant force or the total force acting on Q. Is that clear? So principle of superposition states that if in a system we have more than two charges, multiple charges, then in order to calculate the total force on a given charge, we have to take the vector sum of all the forces acting on that given charge. So let us solve a problem related to this concept so that the concept will be more clear to you. So now look at this diagram. Here we have an equilateral triangle ABC, and the length of each side is L. At the three vertices we have three charges. At A we have a charge plus Q, at B we have a charge plus Q, at C we have a charge minus Q, and we have to calculate the resultant force acting on this negative charge minus Q. So in this system we have three charges, Q, Q and minus Q, and we are interested to calculate the resultant force or the total force acting on this charge minus Q. So students, since we have to calculate the force on this charge minus Q, we know that the charge at A and the charge at B will exert some electrostatic force on this charge minus Q. This is negative charge and these two are positive charges. So both of them will attract the charge minus Q towards them. So the force exerted by this charge on this charge will be directed along CA because the force is attractive force. Similarly, the charge at B means this charge will also attract the negative charge minus Q towards itself. So there are two forces, F1 and F2. F1 and F2, these are the two forces, and the angle between the two forces is 60 degree because the triangle is an equilateral triangle. Is that clear? So F1 vector, what will be the value of F1 vector? F1 vector means the force on minus Q due to the charge at A, means due to the charge plus Q. So F1 vector will be how much? K Q into Q. So students, remember that whenever you are writing the expression for force between two point charges, don't write the sign of the charge, just write their magnitudes, don't write the sign. So although this charge is minus Q, I have written plus Q here because in magnitude we should not mention the sign. So K into Q1 into Q2, Q1 is this charge, Q2 is this charge, but while writing the magnitude of force there is no need to write the negative sign. So I have written Q and Q. So K Q into Q divided by distance square. The distance between the two charges is L, so I can write L square here. Is that clear? And the direction of this force is along CA. Along CA. So F1 vector is equal to K Q square by L square along CA. Is that clear? Similarly, let us write the expression for F2 vector. F2 vector means the electrostatic force on the charge minus Q due to the charge plus Q present at point B. So F2 vector will be how much? It will have the same magnitude, K into Q1 into Q2. So Q into Q divided by distance square. The distance is L, so L square, and again it is towards B, means along CB. The direction is along CB. So F2 vector is equal to K Q square by L square along CB. Is that clear? So this is the expression for F1 vector and this is the expression for F2 vector. And you can see that the magnitude of the two forces are same. The magnitude of F1 vector is K Q square by L square, and the magnitude of F2 vector is also the same, K Q square by L square. So I can write that F1 vector magnitude is equal to F2 vector magnitude, that is equal to K Q square by L square. And let us say that this value is X. Let us say that the value, this value K Q square by L square equal to X. So in class 11 we had studied about the triangles law of vector addition, the parallelogram law of vector addition, and we have the formula for the resultant, that R equal to A square plus B square plus 2AB cos theta square root. If we have two vectors A and B, and if theta is the angle between the two vectors, then the magnitude of the resultant is given by this formula, R equal to square root of A square plus B square plus 2AB cos theta. So here A is F1, B is F2, and the angle between them is 60 degree. Is that clear? And both of them have the same magnitude. So F1 magnitude and F2 magnitude, that is equal to X. So the total force, the resultant of the total force or the net force is equal to how much? X square plus 2xx cos 60 square root. So the formula is F net equal to F1 square plus F2 square plus 2F1 F2 cos 60, but F1 and F2 they have the same value and I have taken it to be X. So I have written X square plus X square, means in place of F1 I have written X, in place of F2 I have written X. So X square plus 2xx cos 60 square root. So this will be 2x square plus 2x square, and cos 60 is half. So 2 will cancel, you will get 2x square plus x square, which is 3x square square root, that is equal to root 3x. Is that clear? So this is the magnitude of the resultant force, root 3x. And what is x? X is this value, K Q square by L square. So the magnitude of the resultant force is given by root 3 K Q square by L square. And what will be its direction? The direction of the resultant force will be in this direction. Is that clear? So using the principle of superposition, we calculated the force on the charge minus Q, and in this system we had 3 charges. Okay, so in this way you can use the principle of superposition to calculate the total force on a given charge in a system having multiple charges. So now we'll solve a few more problems related to the concepts in the previous class. In the previous class we had discussed about Coulomb's law. So let us now solve few numericals based on that concept as well. So now let us solve this question. The question is, a free pith ball A of 8 gram carries a positive charge of 5 into 10 to the power minus 8 coulomb. What must be the nature and magnitude of charge that should be given to a second pith ball B fixed 5 centimeter below the former ball so that the upper ball is stationary? So let us try to understand this question. The question says that we have two pith balls, pith ball A and pith ball B. The mass of the pith ball A is 8 gram. A ro mass kete? Mass hochi 8 gram, and the charge of the pith ball is how much? The charge is let us say Q1. Q1 is how much? 5 into 10 to the power minus 8 coulomb. Tamane pith ball A is positively charged. Pith ball A is positively charged, and the mass is 8 gram. The question is, what must be the nature and magnitude of charge that should be given to a second pith ball B fixed 5 centimeter below the former ball so that the upper ball is stationary. Stationary meaning at rest. So since this pith ball has some mass, the mass is 8 gram, due to gravity the pith ball should fall down. Is that clear? कहीं ना pith ball रो जो weight आसीबो, weight means m into g, mass दे दीजिए, mass कहते 8 gram. So the pith ball has some weight, and due to that weight the pith ball should fall down. तो ये pith ball रो weight कहते आसीबो, weight आसीबो m into g. Is that clear? किंतु क्वेश्चन ये कौन कहिछि ना आमे सेकेंड pith ball को केते अमाउंट रो चार्ज दबा, आ से चार्ज रो नेचर कौन हबो? नेचर मीन्स से चार्ज टा पॉजिटिव चार्ज ना नेगेटिव चार्ज हबो, so that the pith ball A will not fall down, it will be at stationary. तो को केस रे को कंडीशन रे pith ball A टा रेस्ट रहिबो if the weight mg is cancelled by some other force. And what is the other force? The other force is the electrostatic force, because pith ball A is charged. जदि मैं pith ball B को किसी चार्ज दबा, then there will be electrostatic force between the two pith balls, and that's why if that electrostatic force will cancel the weight, then what will happen? The pith ball will not fall down, the pith ball will be at rest. ता माने the electrostatic force between the two pith balls should be opposite to the weight. The weight is downward, it means the electrostatic force between them should be upward. The electrostatic force Fe should be upward. Pith ball A रो चार्ज पॉजिटिव, ता माने जदि मु pith ball B को नेगेटिव चार्ज दे देबी, pith ball B A को अट्रैक्ट करिवो डाउनवर्ड, ता माने सेही केस रे इलेक्ट्रोस्टैटिक फोर्स टा वेट रो ऑपोजिट रे रहिबो नाही, ता माने pith ball B को पॉजिटिव चार्ज दवा को पड़िबो. The pith ball B should have a positive charge, so that पॉजिटिव रिपेल करिवे, ता माने pith ball B A को रिपेल करिवो upward direction रे, and here you can see that the electrostatic force will be opposite to the weight. ता माने जदि Fe equal to mg हे गला, then the two forces will cancel each other and pith ball A will be at rest. So Fe रो वैल्यू केते हबो? 1 by 4 pi epsilon naught q1 q2 by r square, that is equal to mg. So 1 by 4 pi epsilon naught रा वैल्यू केते? 9 into 10 to the power 9 into q1 रा मीनिंग कोन? q1 is the charge on the first pith ball, and the value is 5 into 10 to the power minus 8 coulomb, into we have to calculate the magnitude of charge on the pith ball B. So write q2 here, okay, divided by r square. R केते कहि r कहि 5 centimeter, but remember that whenever you are solving a numerical, you have to always express the quantities in SI system. So you have to convert the distance from centimeter to meter. So 5 centimeter is 5 into 10 to the power minus 2 meter. So 1 by 4 pi epsilon naught value hochi 9 into 10 to the power 9. This is q1 into q2 divided by r square. This should be m into g. M kete kahichi? Mass kahichi 8 gram. Again this is in CGS system. Ame to SI convert kariba. So 1 gram is equal to 10 to the power minus 3 kg. So it is mass 8 gram deichi. So 8 gram means 8 into 10 to the power minus 3 kg into g. Let us put g equal to 10 meter per second square. Is that clear? So from this formula you can easily calculate q2. ठीक अछि? तो बाकी calculation part you can solve on your own. So this is the method in which you can solve this question. So now we'll go to the next one. Now look at the next question. The question is, a particle of mass m and carrying a charge minus q1 is moving around a charge plus q2 along a circular path of radius r. Prove that the time period of revolution of minus q1 about plus q2 is given by t equal to square root of 16 pi cube epsilon naught m r cube divided by q1 into q2. So we have a charge minus q1 which is revolving around a positive charge of plus q2. Suppose at the center we have a charge plus q2 and around the charge plus q2 we have another charge minus q1 which is revolving, and the radius of this circular path is r. We have to prove that the time period of revolution of the charge minus q1 about the charge plus q2 is given by this value. So students, remember that if we have two unlike charges, there will be attractive force between them. So the attractive force between the two charges, means between the charge minus q1 and plus q2, will be how much? 1 by 4 pi epsilon naught q1 q2 divided by r square. This is the electrostatic attractive force, and the force will be toward the center. ता माने माइनस q1 उपरे q2 जो फोर्स एक्सर्ट करिवो से फोर्स रो मैग्नीट्यूड केते 1 by 4 pi epsilon naught q1 q2 by r square, and the direction will be towards the center. Is that clear? In class 11 we had studied that when a particle moves in a circular path, it requires a centripetal force, and the centripetal force is always directed towards the center along the radius. So in this case, the electrostatic attractive force is along the radius towards the center. ता माने ए केस रे electrostatic force of attraction provides the required amount of centripetal force. Centripetal force रो value केते m v square by r. Is that clear? Fc equal to m v square by r. M is mass of the charged particle, v is the speed with which it is revolving around plus q2, and r is the radius. ता माने this centripetal force is provided by the electrostatic force of attraction. Is that clear? So I can write that m v square by r is equal to 1 by 4 pi epsilon naught q1 q2 by r square. So here r and r will cancel. So v square kete asibo q1 into q2 divided by 4 pi epsilon naught mr. This m will be divided here. Is that clear? So if v square is this much, then v kete asibo? V asibo square root of q1 q2 divided by 4 pi epsilon naught mr. Okay, so this is the speed with which the charge minus q1 is revolving around the charge plus q2. तो वर्तमान आमे टाइम पीरियड बाहर करिबा. तो टाइम पीरियड रो फार्मूला कोन हबो? time period means the time taken by the charge minus q1 to complete one revolution. Okay, so jodi charge minus q1 gote complete revolution karibo, then the distance covered is equal to 2 pi r. So the time is how much? Distance by speed. So 2 pi r distance को v speed रे move करिवो तो केते टाइम लागिवो? t equal to 2 pi r by v. So 2 pi r by v. So in place of v I can put this value. So केते आसीबो आंसर ना 2 pi r into 1 by v. 1 by v means take the reciprocal of this quantity. So this will be 4 pi epsilon naught mr divided by q1 q2 square root. Is that clear? Now if I take this 2 pi r inside the square root symbol, so kete he jibo 4 pi square r square he jibo. Is that clear? And we have 4 pi epsilon naught mr divided by q1 q2. So 4 into 4 will be 16, then pi square into pi will be pi cube, r square into r will be r cube, and here we have m, then we have epsilon naught m r cube divided by q1 into q2 square root. Okay, so we prove that the time period of revolution of the charge minus q1 about the charge plus q2 is given by this expression. T is equal to square root of 16 pi cube epsilon naught m r cube by q1 into q2. So in this way you can solve this question. And now we'll go to the next one. So now look at the next question. The question is, two identical charges capital Q each are kept at a distance r from each other. A third charge small q is placed on the line joining the above two charges such that all the three charges are in equilibrium. Equilibrium means the net force on all the charges is 0. What is the magnitude, sign and position of the third charge small q? So let us draw the diagram first. So we have two identical charges plus q each, and they are kept at a distance of r from each other. Suppose point A रे plus q charge achi and point B रे again plus q charge achi, and the distance between them is how much? The distance is r. Okay, now we'll bring a third charge small q, but आमे जानने जे small q रो sign कौन, माने small q टा positive charge किंबा negative charge, we don't know about that. So we bring a third charge small q and placed on the line joining the above two charges. Suppose third charge को मो A point रे place कली. Okay, suppose at point C I place the third charge q, and after placing the third charge q, all the charges they are in equilibrium. Okay, equilibrium रा meaning कौन ना सबो charge ऊपर जो तीनटा charge अच्छी, the net force on all the three charges is 0. ता माने plus q ऊपर net charge 0, plus q ऊपर net charge 0, and small q ऊपर भी net charge 0 है जो. So we have to find what is the magnitude of this charge small q, and what is the sign. Sign means तारा value तारा polarity positive बा negative ताको में बाहर करिबा, and what is the position of small q. ता माने small q टा को place रे में ताको locate करिबा. Okay, suppose small q is placed at C, and suppose assume that the distance of C from the left end A is x. Suppose the distance of C from A is x. So distance of C from B केता आसीबो? R minus x आसीबो. Is that clear? And according to question, all the three charges are in equilibrium. ता माने सबो charge उपरे net force 0. So let us take the charge small q, and we know that small q is in equilibrium. According to question, small q, this plus q and this plus q all are in equilibrium. So to find the position of small q, let us consider the equilibrium condition. Consider the इक्विलिब्रियम कंडीशन ऑफ स्मॉल q। तो स्मॉल q ऊपर a प्लस q और a प्लस q फोर्स एक्सर्ट करेंगे। इज दैट क्लियर? तो there are two electrostatic forces acting on small q, but in the question it is given that small q is in equilibrium। ता माने the force exerted on small q due to this charge should cancel the force exerted on small q due to this charge। okay, तो F1 माने कौन? force exerted on this small q due to the left charge। सेटा केते हबो? k capital Q into small q divided by x square। okay, and F2 means what? Force exerted on the charge small q due to the right charge। तो F2 केते आसीबो? k into again q1 q2 by distance square, so capital Q into small q by what is the distance? The distance is r minus x, so r minus x whole square। okay, so these are the two forces acting on small q, but in the question it is given that small q is in equilibrium। ता माने these two forces should cancel each other, means the two forces should have the same magnitude and they should be in opposite direction। so जदि मो f1 equal to f2 put कली, because जदि f1 और f2 रे value same ना हो, then they can never cancel each other। ता माने f1 and f2 should have the same value। so f1 equal to f2 हमें दे put करिबा, I can write that k capital Q small q divided by x square is equal to k capital Q small q divided by r minus x whole square। so it cancel ejibo, we will get r minus x whole square equal to x square। okay, now take the square root on both side, तो r minus x केते हे जिवो x हे जिवो, तो r केते हे जिवो x plus x बा 2x, so x केते हे जिवो x हे जिवो r by 2। so x is found to be r by 2। ता माने the distance of point C from the point A will be r by 2। तार मीनिंग कोन? तार मीनिंग कुछ या जे the third charge small q will be placed at the midpoint of the line joining the two charges। is that clear? ता माने AC हबो r by 2 आउ CB हबो r by 2। is that clear? तार अर्थ कोन ना थर्ड चार्ज q टा कोठी लोकेट हबो at the midpoint of the line joining the two charges। so we have found what is the position। okay, now we'll find what is the magnitude and what is the sign, means whether small q will be positive or negative। so एबे देखो small q रो sign जदि positive हुए then कौन problem हबो? so here I have plus q charge, here I have the second charge plus q, and at the midpoint I have the third charge small q। okay, so जदि small q रो polarity बा sign जदि positive हुए then no doubt small q will be in equilibrium। काहे कि ना left charge positive अछि, right charge positive अछि, जदि middle charge टा positive हे जिवो then no doubt this charge small q will be in equilibrium। काहे कि ना this positive charge will repel small q towards right and this positive charge will repel small q towards left, so these two forces are equal and opposite, so semane cancel kari jibe। tamane small q ta equilibrium rahibo, but the right charge and the left charge they can never be in equilibrium। jodi small q ta positive he jibo then no doubt it will be in equilibrium, but the left charge and the right charge can never be in equilibrium। kahe ki if I consider the right charge, the right charge equilibrium pai condition kon dakar, tapore net force 0 ha dakar। tabe dekho the first charge is positive, ta mane this charge will repel this charge towards right। okay, and again this small q charge is positive, ta mane this positive charge, this small q will also repel this capital Q towards right. ta mane these two forces they have the same direction, ta mane se add he jibe, se mane cancel karibe nahi. ta mane जदि मैं स्मॉल q रो साइन को पॉजिटिव नौचे then only small q will be in equilibrium, but the other two charges, the left charge and the right charge will never be in equilibrium. किंतु जदि आमे स्मॉल q को नेगेटिव नहीं जिबा, जदि स्मॉल q टा गोटे नेगेटिव चार्ज हुए ताहले कोन हबो ना this positive charge plus q will repel the charge towards right, but this negative charge will attract, this negative charge means the small q will attract capital Q towards left. ta mane the two forces are opposite to each other and there is a possibility that they will cancel each other. किंतु जदि हमें small q को positive नहीं जिबा then the two forces will have the same direction and they will be added out. So meaning so we got to know that the sign of the charge will be negative. Okay, ame position pale the position is at the midpoint and the sign is negative. Now we have to find the magnitude. ta mane ame small q ro value को express करिबा in terms of capital Q. Okay, so consider the equilibrium, consider the equilibrium of the second charge. ये जो सेकेंड चार्ज अच्छी सेकेंड चार्ज रो इक्विलिब्रियम हमें कंसीडर करिबा. तो ये सेकेंड चार्ज ऊपर ले फर्स्ट चार्ज फोर्स पकेबो और थर्ड चार्ज भी फोर्स पकेबो. तो F1 केते आसीबो, F1 मींस द फोर्स ऑन दिस चार्ज ड्यू टू दिस चार्ज, सेटा केते हबो K Q1 into Q2 means Q into Q divided by distance रो स्क्वायर. तो डिस्टेंस केते, डिस्टेंस होची r, so r स्क्वायर हे गेला. ओके, सो दिस इज इक्वल टू k q स्क्वायर by r स्क्वायर and that force is towards right F1. now F2 रो मीनिंग कोन, force on this charge due to this small q charge. ओके, सेटा केते आसीबो k into small q into capital Q divided by this distance square माने CB रो स्क्वायर और CB केते, CB होची r/2, so it will be r/2 square. तो एटा केते हिजबो k q by r square by 4. this 4 will go to numerator, तो एटा केते हिजबो 4k small q capital Q by r square. so F1 and F2 they are opposite in direction. जदि सेमानकर मैग्नीट्यूड सेम हे गला then they will cancel each other and this charge will be in equilibrium. Okay, so for equilibrium F1 must be equal to F2. if they are not equal then that right charge will never be in equilibrium. so if I put F1 equal to F2 then I will get k q square by r square equal to 4 k small q capital Q by r square. so k cancels, r square cancels, q एटी गोटे q cancel हे जिवो. so 4 small q equal to capital Q, that implies small q केते आसीबो capital Q by 4. ता माने आमे small q रो मैग्नीट्यूड को एक्सप्रेस कले in terms of capital Q. this is the magnitude of the third charge small q and its sign is negative. ता माने small q केते आसीबो minus q by 4. the magnitude is q by 4 and its sign is negative. so students in this way you can solve this question. so hopefully ajira class रे जितिक सब question discuss कले you have understood everything and in the next class we'll discuss about a new topic which is electric field and the formula to calculate electric field due to a point charge. so till then bye bye and have a nice day.